One of the most spectacular and most watched recurring astronomical events is an eclipse of the sun. Professional astronomers, amateur astronomers, and simple enthusiasts alike may travel the world just to watch an event that lasts only a few minutes. Though truly a wonderful and awe-inspiring event, total solar eclipses are not necessarily rare. They happen almost every year. For some dedicated watchers, the annual family vacation may be decided by the location of a solar eclipse. A solar eclipse occurs simply when the moon passes directly between the sun and the earth. However, the moon is not the only celestial object that can pass between the sun and the earth. There are others, and only two others. Do you know what they are? Not comets, not asteroids. They are the planets Mercury and Venus, both of which orbit the sun closer than the earth. As such, they are the only celestial objects other than the moon that can pass between the sun and the earth. When these orbits line up properly, we can see these planets crossing the disk of the sun in our sky. This event is known as a transit. While perhaps not as visually stunning as a solar eclipse, transits are rare and therefore not events to be missed. To really understand and appreciate why transits occur and why they are rare, we must identify two pathways in the sky. The first path is called the ecliptic. By definition, it is what we see when the sun appears to move over the background stars throughout the year. This is a very intuitive definition. We see the sun move across the sky every day. And even though during the daytime we can't see the stars behind the sun, we can calculate, plot, and visualize the sun's path across the star field. However, we know the sun does not really move in the sky. It is the Earth's orbit around the sun that gives this illusion. So perhaps a more accurate definition of the ecliptic is the plane generated by Earth's orbit, or Earth's orbit stretched out into space. Now that we have Earth's orbit drawn, we can introduce a third and less formal definition. The ecliptic is the plane of the solar system. This is the other pathway in the sky we need to identify. The orbits of all the major planets lie very close to, though not exactly on, the ecliptic plane. The planetary system is really quite flat. All the major planets orbit across the ecliptic, but never get too far above or below. This includes Mercury and Venus. Three things must line up in order for a transit to occur. First, the planet's orbit must be really close to the ecliptic, like so. Second, its orbit must be between the Earth and the Sun. Finally, the timing of a transit will happen when Mercury or Venus, our Earth and the Sun, line up accordingly at the precise moment. When all three occur, those on the daytime side of the Earth will be able to see the planet move across the face of the Sun. For Mercury, there were 14 transits in the 20th century, and there are 14 to occur in the 21st century. Mercury transits are difficult to see because of Mercury's small size and require the aid of a really good pair of binoculars or a telescope. Solar filters must be used for all transits. The next two transits of Mercury occur in 2016 and 2019. Transits of Venus are more easily observed. Venus appears much larger than Mercury, so the transit of Venus can be viewed with the unaided eye. Venus will appear as a small dark disk slowly moving across the face of the Sun over a period of several hours. Again, proper solar filters must be used, whether viewing the transit under magnification or not. Venus transits are much more rare, always occurring in pairs, 8 years apart, with about 110 years between each pair. The last transit of Venus was in 2004. Our next transit of Venus is on June 5th through the 6th, 2012. It begins at about 10:15 p.m. Universal Time and ends 6.5 hours later at about 4:45 a.m. Universal Time. This means that most of North America will be watching the transit as the sun sets on June 5th. Most of Europe, the Middle East, and the eastern half of the African continent will be watching the transit after the sun rises on the 6th. And much of the Orient, Australia, and New Zealand will be able to see the entire transit. If you miss this one, you'll have to wait until December of the year 2117 for the first of the next pair. So don't miss out. Talk to your planetarium, science center, or museum staff about viewing the transit in your local area. And join us next time for another Your World in a Minute from Starlight Express.